Hello everyone and welcome to this class for Introduction to Chemistry, Atoms and Bonds. We're off with talking about atoms, which are the smallest unit of an element. They are the building blocks of molecules, which are made up of matter, the stuff we're made of, and matter is anything that occupies space and has mass. Now, matter is composed of elements. Speaking of elements, we'll go to the periodic table of elements, and you will see that the elements are all abbreviated by their symbols. The first letter is always capitalized and the second is in lowercase, and they are grouped into columns which have similar properties. For example, you have here the first column, which is metals. The second column too as well, which is metals. Here. Metals. And then you have the last column, which are gases, going down. And then you have here group 17, which is the halogens, fluoride, chloride, bromine, iodine. And then going across, you'll see that they are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth. They are numbered across in order of atomic number or proton number. And then you'll see on the bottom here, this number is the atomic mass, which is the mass of protons and neutrons combined. So to show you the closer look of an atom, you have here the nucleus, which consists of the protons and neutrons. Protons and neutrons, they make up the mass in the nucleus. So all the mass is in the nucleus. And then you have here the ones that have charge are the protons and electrons have charge. You can see here positive charge for the protons and negative for the electrons, and you will see that protons always equals the number of electrons, because for every proton there is an electron attracted to it. Remember, positive attracts negative. Positive always attracts negative. So proton is equal, number of proton always equal to number of electron. And because number of proton is atomic number, that's also equal to them. Atomic number. So these will always be equal in number. Now, they're not always stable, these atoms. They'll only be stable when they have 8 electrons in their outer shell. Takes us to valence electron shell theory, which states that it states they're unstable unless their outer shell is filled to a capacity of 8 electrons. Okay, so what they do to become stable is they form bonds. As you can see here, oxygen only has 6 electrons in its valence shell, so it needs 2 more. So what it does, it forms bonds. Here, hydrogen has 1 electron, so it bonds with it. Hydrogen here, and now you got water. 2 hydrogens, an oxygen, you got H2O, water, and now oxygen is happy because it's sharing. Through sharing, it has its 8 valence electrons. Valence shell is the outer shell, and that's the one that needs to be satisfied with 8. Now, the first shell cannot have more than 2. You will see each first shell has only 2. Now here carbon, now the other shells can have up to 8, but the first shell not more than 2. And here you see carbon has a total of 6 electrons, 2 in the first, so the 4 are here, and actually this one didn't exist here, it's only 4. 1, 2, 3, 4, and then you have to form bonds with another atom, say hydrogen here it can form 4 bonds because it only has 4 in that outer shell. It needs 4 more, so it forms 4 more, and now it has its 8 in its valence shell, and now it's satisfied and stable. Now for my class, they can go ahead and pause here and read this summary of what I went through, what I just explained. And then now isotopes. Isotopes are the same type of element that different number of neutrons but have the same number of protons. Okay, for example, carbon-12. Carbon-12 has 6 protons and 6 neutrons. Okay, and that's how it's seen in the periodic table. But then you have these isotopes that will have more neutrons. They have 1 more or 2 more neutrons, making it 7 neutrons, 8 neutrons, and that lets them have more mass. Okay, because neutrons add to their mass. Now, what are they used for, these isotopes? They are used for carbon dating. Means that we can find out how old a bone is. Like when they dig up these dinosaurs and they look at the carbon inside the bones, they're able to tell from the carbon isotope how old the dinosaur is, which is really interesting. And now here I'm gonna do an example. Okay, if we are given the element sodium, okay, and we know that its atomic number is 11. So sodium with the atomic number 11. Okay, and then mass is 23, and we're asked to find the number of neutrons. And number of protons. And number of electrons. Now, how do we find them? Now, remember, atomic number, as I said, atomic number is equal to number of electrons and equal to number of protons. Essentially is the same thing. They are the same thing, atomic number and proton number. So they're giving us atomic number, so I know right away proton number is 11 and electron number is 11 because they're the same thing. Now I need number of neutrons. Remember, mass is equal to number of neutrons and protons. So what I do is subtract 23 is the mass minus number of protons, and now you know it's 12. So number of neutrons is 12. And that's it for this video. Thank you for watching.